Hello, Professor. This is Gayatri Chilukala. Today I'm going to present the analysis of algorithm project. Coming to the overview of the project, we need to find the closest pair of points. I have implemented two algorithms. One is the brute force approach and other is the divide and conquer technique. Coming to the brute force approach is a straightforward approach of comparing all the possible pair of points and determining the closest one. Coming to its implementation, here is the algorithm in the CPP. Here we see the structure point has x and y coordinates, and for the closest pair indices index 1 and index 2, we will update it with the closest pair indices and closest pair. This is a constructor initialized for the random number generation. Calculate distance function will find the Euclidean distance between the given set of points, and brute force closest points function will find the closest pair by comparing each and every possible points and return the indices of the minimum distance. And next, generate random points function will generate n random unique values within the given range, that is 15k to 60k. And next, we have the measure runtime, which is going to measure the runtime m times for the brute force technique and return it in the milliseconds. And next, the main function, we have n is equals to 100 and m is equals to 10, which was the base case, like the simple case I'm taking to run the code. Here is the generate random points, which is going to generate 100 unique random points, and we are going to pass it to the measure runtime code and also the m iterations. After passing it here, we see that we are calling the brute force approach. It is going to calculate the average runtime here and convert to milliseconds and return to this function, and this is going to print. When we run the code, we get the average runtime for n is equals to 100 as 0.3079 milliseconds. Coming to the next approach, that is divide and conquer approach. In this approach, we have a base case. If the n is less than or equal to 3, we directly apply the brute force algorithm. And next, if it's n is greater than 3, then we have to first sort the coordinates, x and y coordinates. Next, the divide approach. The divide, we need to divide until the base case, and conquer, we have the delta L and delta R. In the combined, we need to take the minimum value from the delta L and delta R. Coming to the implementation of the divide and conquer technique, we have implemented in the CPP code as part of the structure pointer. It has x and y coordinates. Double Euclidean distance will calculate the distance by applying the distance formula between P1 and P2. And next, we have the brute force closest pair, which is applied when the px dot size is less than or equal to 3. This is considered as the base case, as explained before. Next, if not, the divide and conquer technique is applied. We are going to divide the points into two parts. One is the qx and the rx. In the same way, one is the left part of it and the other is the right part of the midpoint. So in the same way, it's for qy and ry we find out. After that, we recursively apply the closest pair for qx and qy and rx and ry. After that, we need to determine the minimum delta, which is, after finding the minimum delta between the 2 points, build a vector sy. After building containing the points from P1 whose x coordinate is within the delta distance from the midpoint, we will iterate over the points in sy and find the closest pair of points whose distance is less than the delta. After that, we will return the closest pair. How do we return the closest pair? We compare the closest pair with the delta. If the minimum split is less than the delta, then we return the closest split pair. Else, otherwise, the closest pair is amongst the closest pair left or closest pair right. Next, we have the closest pair function. Here, we will just sort the coordinates with respect to x, with respect to y. And next, generate random points. Generate points function will generate n unique points within the given range, that is 15k to 60k. And next, we have the measure runtime, where we are going to measure the runtime of the divide and conquer technique for m iterations. Here is the main function. We have n is equals to 100, m is equals to 10, and we are going to first generate n random points and pass it to the measure runtime. We divide it by m because this function is returning the total runtime. For m iterations, we divide it, we get the average runtime in milliseconds. Run the code. We see it's 0.19, which is less than the brute force approach, because for the brute force approach, we got 0.3079. So coming to the conclusion of the project, the brute force approach takes more running time than the divide and conquer technique. I have tried for the huge input size from 10 power 4 to 10 into 10 power 4 for both the brute force and the divide and conquer. As the input size increases, the runtime also increases. We can see that. But For the brute force, it is consuming more time. For the divide and conquer, it's consuming less time. As the conclusion, divide and conquer is the more efficient algorithm than the brute force technique for the large input size. Thank you. This is about my project.